Hi everyone. Welcome to the post-contest discussion of today's Leetcode round 430. This is TLE Eliminators, and I am Soumojit Chatterjee. Today we will discuss the first three problems of the contest. So I just hope that you all had a fun contest. So before discussing anything further, someone please confirm in the chat whether I am clearly audible or visible and not. Okay, great. So let's start with today's discussion. I would like to inform you that you all have permissions to unmute your mic. So if at any moment you feel that the explanation is a bit unclear, or maybe you have some problem with the voice or the screen, or maybe you need one more dry run, then quickly tell me. Okay, so let's start with the first problem of the contest. So here is how it goes. It says minimum operations to make columns strictly increasing. So the question says that you are given a m cross n matrix grid consisting of non-negative integers. In one operation, you can increment the value of any grid ij by 1, and it asks to return the minimum number of operations needed to make all columns of grid strictly increasing. Okay. And then there is an example test case given. So let us start with this example test case. Let me just write down what the test case is. Okay, so what we have collected so far is that in the input, we will be given a m cross n grid of integers. We will be given an m cross n grid of integers. Okay, that's great. So let's take a sample input. So here is the input they have given 3, 2, 1, 3, 3, 4, and 0, 1. Okay, so let me write it down 3, 2, just a second, 3, 2, 1, 3, 3, 4, and 0, 1. Okay, so 1, 3, 3, 4, and 0, 1. I hope I copied it right. 3, 2, 1, 3, 3, 4, and 0, 1. Now look at what the question says. The question says that in one operation, you can increment the value of any grid ij by 1. That means the question actually allows us to do some operation. So in one operation, what can we do? We can pick some integer and increase the value of it by 1. So let me write what does an operation gives us power. So in one operation, you can pick any element. So you can pick any element x in the grid, and in just one operation, you can change it to x plus 1. So I hope it's clear, quite simple operation. And now what does the question asks us to find? Read this. Return the minimum number of operations needed to make all columns of grid strictly increasing. Okay, just a second. Yep. So it asks to find the minimum number of operations needed to make all columns of grid strictly increasing. So basically, you can always think this grid as a bunch of columns, right? So here is a column, and similarly here is one more column. So there are two columns, right, in this grid, and the question asks that you have to make all these columns strictly increasing by some sequence of operations. Okay. So what does strictly increasing means? So quickly, just telling you, though it's a very standard definition, what does strictly increasing means? So basically, if you have a set of numbers, say a1, a2, an, then for strictly increasing, for this sequence to be strictly increasing, you basically need that ai has to be strictly less than ai plus 1 for all i. So I hope it is clear that at every step when you jump, basically the value should increase. That means, just for the sake of an example, 3, 5, and 8 is a strictly increasing sequence, whereas 2, 3, and 1 is not a strictly increasing sequence, right? Similarly, 2, 2, 4 is also not a strictly increasing sequence because here the value does not strictly increasing. This strict inequality is not satisfied here. Okay, so I hope that is clear. Now, what does the question asks? The question asks that you independently take every column, and in every column you need to ensure that this becomes strictly increasing. Like, look at this column. Here, what are the values? You first have a 3, then you have a 1, right? So this is not strictly increasing. The value decreased here. So we have to do some operations on this column so that the value becomes strictly increasing. And the question asks how many minimum operations we need to perform. So I hope the question is clear. Can someone please confirm in the chat whether the question is clear or not? Great. Okay. So now first thing you have to understand is two operations on two different columns are completely independent, right? Like if I perform a operation on this one, it will never affect the statistics of this column basically, because this column, the operations on this column only affect itself and does not affect anything others. That means I can solve this problem independently for all the columns. So the first thing we can do is iterate over all the columns, extract them, and try solving for this column, what is the minimum number of operations required. So if I can find the minimum operations for each column separately, I can just add them up to get the answer. So I hope it's clear. So let's try solving the question for each column separately. So let me take the first column, say 3130. So let's start. So here is the first column I have. Let me write it down horizontally for as it helps to view better. So let me write it 3130. I hope you all remember what the operation is. So what the operation is, it's simply taking some element x and converting it to x plus 1. So that's clear. And this is one operation. And I need to minimize the number of operations and have to make this strictly increasing. So there are few observations you can make. The first one is simply that a value can never be decreased. So this is 3, right? In one operation, you can just increase a value. You can never decrease it. So that means this 3 can never be decreased. So it has to remain 3 forever. So if I try to make a final array, this 3 can be just copied, right? So this 3 just remains 3. Okay, so because this can't be decreased, and realize that there is no sense increasing this value, right? Because if you increase this value, then suppose you increase this value to 4, then you have to increase these values a lot more to make the array strictly increasing, isn't it? So that means if you increase this value unnecessarily, that will require more operations than required, and you will never achieve the minimum number of operations. So I think the first thing is clear, that it always makes sense to just copy the first element. Okay, that's great. Now think about the second one. Obviously, we can't just copy a 1, because if we copy a 1, then the sequence will have a 3 and then a 1. So it will not remain strictly increasing, right? So this is not possible. Okay, so think about this. What is the minimum element you can have here? So since this is 3, and since the array has to be strictly increasing, so suppose this value is some x. Since the array is strictly increasing, x has to be strictly greater than 3, right? And this inequality is strict. An equality condition even does not imply strictly increasingness. So since x has to be greater than 3, what is the minimum value of x? The minimum value of x is 4, right? So minimum value of x is 4. That means at this operation, at this position, the minimum element I can add is 4. So that means I have to do at least 3 operations here. Here, I have to do at least 3 operations so that the value becomes 4. Now you may ask, okay, why not increase this value a lot more? Why not make 9 operations on this and make this 10? You can do that, but that will just unnecessarily increase the number of operations, right? You need to solve this problem in a minimum number of operations. So it is always optimal to increase as less as required. Here, increasing 3 was necessary, otherwise the array would not remain strictly increasing. So I increased 3. Increasing more than 3 is not necessarily, it will just be a wastage of the operations, which will not help us achieve the minimum operations. So I just used 3 operations here. Now look at this position. What is, how many operations do I need this position? Because I have a 4 here, notice that I need at least a 5 here. So that means since I need a 5 here, I have to do 2 more operations here. So I have to do +2. So if I do a +2, this 3 becomes a 5. Great. Similar logic. Since this is a 5 here, that means I need a 6 here, right? So since I need a 6 here, how many operations do I need to make? 6, isn't it? So I've made 6 operations here. This value becomes 6. So what is the total number of operations I did? That is simply 3 plus 2 plus 6. That's 11 operations, right? Now notice that for this row, 11 operations is the optimal one. Why? Because at every step, when I moved from left to right, at every step, I always ensured that the value I get is the minimum one. I always do the minimum number of operations possible, so that I do not increase the value more. For any other sequence of operations which keeps the final array strictly increasing, you will obviously need more than 11 operations, right? Great. So, for example, say I could do a different sequence of operations. Like for this same 3130, I could make 4 operations here. This value would have become 5. But then I would have to do more operations here to make it 6. And I have to do more operations here to make it 7. And that would unnecessarily increase the number of operations. That means the minimum number of operations is when you assign the next element to be just the previous element plus 1 at max, because increasing more than that would be completely unnecessary. So what did we find out? We find out that for this row, the answer is 11. Great. Now let's have a look at this row. 2, 3, 4, 1. The logic remains exactly the same. So I have a 2, 3, 4, and a 1. And now I need to convert it to a new array using some number of operations. Just a second. Yeah, great. So now, as our previous argument, it always makes sense to just copy the first value, increasing this because here there is no condition on strict increasingness, and increasing this would unnecessarily increase the number of operations. So we keep it at 2. Great. Now, note that here I do not actually need to do any operation. I can just copy paste 3, right? Because that would the strictly increasing condition would still remain valid, right? So I just copy pasted 3 here. The same logic, I copy pasted 4 here. So I do not make any operation here because just copy pasting stuff keeps the array strictly increasing. So that's great. We do not need to make any extra effort increasing them, right? But look at this position. I can't just copy paste 1 here, because if I copy paste a 1, this strict increasing condition would become invalid. So what is the minimum position element I can make sit here? I can place 5 here, right? Because for this is 4 and I have to keep this strictly increasing. So I have to add a 5 here at least. So that means I need to do 4 operations here. So that means for this column, in a total, I had done 4 operations. Okay, great. So the number of operations I here required is 4. So now we have independently solved for each column, 11 for the left column, 4 for the right column. The total number of operations we made on the entire grid is simply the sum on each column. That's 11 plus 4. That's equal to 15. So that's our answer. Let's verify once. Yep, 15 is given as the answer. So I think the logic is clear. Probably, okay, let's have a look at my code once so that you get a clear idea of what is actually happening. So basically we took grid as input. Then we took M. So M and N are just sizes of the grid. So that's completely fine. Now what I did, I am iterating over I from 0 to N. That means, now what is N? N is the number of columns, right? So that means I am basically iterating over all columns. So this is same as independently solving the problem for each column. Great. Now, how I am solving the problem? I start from j equal to 1, and then I check that whether grid ji is greater than equal to the previous element grid j minus 1i. Why so? Basically, the logic is exactly same as I explained. Basically, so if I have an if I suppose this is some column a1, a2, a3 dot dot say some am, this is some column. I basically come at the second element, and then I check whether this is less than equal to the first element. So if I see that okay, a2 is less than equal to a1, so that means the strictly increasing condition is not valid, right? So that means I have to do operations here. How many operations do I need to do? I basically need to do a1 minus a2 plus 1 operations, isn't it? Because doing this operations on a2 would make the final value a1 plus 1, and that's what we required, right? We wanted, since this was a1 here, we wanted a1 plus 1 here, right? We just need an increment of plus 1. So I have to do a1 minus a2 plus 1 operation, but I have to do it only when the current element is less than equal to the previous element. Why? Because if the current element is already larger than the previous element, I can just copy paste it, right? The way we did here. We do not need to do any more number of operations. So that's what I have done. If grid ji, that is the current element, is less than equal to the previous element, then I have increased the number of operations by the number of operations required to match the current element to previous element plus 1. And finally, I have rewritten the current element as previous element plus 1, and the loop just continues, actually counting the number of operations. Okay, so if there are any doubts, please ask me in the chat, or else please confirm if it's clear so that we can proceed with the next problem. Okay, great. Okay, so let's start with the next problem now. So here comes the second problem of the contest. Frankly, even I did a lot of mistakes here. Today I made many wrong submissions on this problem. So I have done all type of mistakes you all might do. Okay, so let's start. So the question says that you are given a string word and an integer num friends. Great. Now Alice is organizing a game for her num friends. Okay, so num friends denotes the number of friends Alice has, and he's organizing a game for her num friends. Great. There are multiple rounds in the game wherein each round word is split into num friends non-empty strings such that no previous round has had the exact same split. And then all the split words are put into a box. Now the question says that find the lexicographically largest string from the box after all the rounds are finished. Great. Okay. So the question says a lot of things together. So let us, okay, so first let us first understand, before looking into the question, what does lexicographically greater mean? So what does lexicographically greater mean? I am treating this as an independent concept apart from the problem, because this definition comes very, you will see very frequently in a lot of contests in competitive programming. So what does lexicographically greater mean? Basically, suppose I have two strings. Suppose I have cat and suppose I have boy. So basically, lexicographically greater is kind of the dictionary order. So anything which comes before in the dictionary is smaller, and anything which comes later in the dictionary is greater. So for example, think about it like this: cat and boy. Which one of these strings come later in the dictionary? So cat comes later in the dictionary, right? That means cat is lexicographically larger. Similarly, if I have say strings AAA, say suppose I have 5 times A, and I have a string BA. which of these strings is lexicographically larger? So BA is lexicographically larger because it comes later in the dictionary. Okay. So what is the logic of saying some string is lexicographically larger or smaller? It's simple. You just iterate over the characters in the string. So you just start from the left end and keep on iterating over the characters of the string. Whenever you found a larger character, and in whichever string you found a larger character, that string is lexicographically larger. For example, here B was larger than A, right? Here, the first character here is B. The first character here is A. B is larger than A. That means this string is lexicographically larger. Similarly, here you have a cat and a boy. So cat, the C of cat is larger than B's boy. So cat is larger than boy. So just for the sake of an example, suppose you have two strings, say Alice and ant. Here, you just start from these two left pointers. Okay. So you see that, okay, both these strings are equal. Both these characters are equal. So you just move one pointer to the left. Look at L and N. Now you see that, okay, N comes after L. That means, so this string is lexicographically larger. So you just basically move from the left pointer from left to right. And wherever you get the first character which is not matching, look at which character is larger. You see N is larger. That means ant is lexicographically larger than Alice. Similarly, suppose you have two strings AAAB and AAABA. Whenever you see that one string is completely the prefix of another string, so that means you have started the two pointers from the left, you have moved the entire direction, and you have not found you have found all matching characters, but finally one string has ended. In that case, the string which is larger is lexicographically larger. So these are just definitions. In the problem itself, this is written: a string A is lexicographically smaller than a string B if in the first position where A and B differ, string A has a letter that appears earlier in the alphabet than the corresponding letter in B. And if the first min of A length, comma B of length characters do not differ, this basically means that at least one of the strings is a prefix of the other string. Then the shorter string is a lexicographically smaller one. So I hope the definition is clear. Now let me explain what does the problem wants. The problem says that as a part of the input, you are given a string which is word. And you are also given an integer which I will call num. They have called it num friends. Let's call it num in short. Great. Now it says that you have this string word. So you have this large string. So let this be the string s1, s2, dot, 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 sn. So basically n is the length of the string. So the question asks that you split the string into k different partitions. So basically you split the string into different partitions. So here is a partition, here is a partition, here is a partition, here is a partition. So you split the string into k different partitions. And you can split it in any way you wish. And you have to tell what is the lexicographically largest possible partition you can get. So that is what the question asks for. For example, I think it will be clear if you look at this example test case. Consider word as the string dbca, and it has given that num friends is 2. That means basically we need to break this string into two different partitions. So look at this. What possible splits we can make out of dbca? If we have to split this string dbca into two different parts, these are the possible splits, right? D, BCA, DB and CA, DBC and A, right? Note that out of all these possible strings, the lexicographically largest possible string is DBC. So that is given as output. So I hope it is clear. Basically, the question says that you are given a string word, you split it as as your wish into num friends number of partitions. and then split and then return the lexicographically largest string you can get. Similarly, here there is a string GGGG, and it has been said that numFriends is 4. That means basically you have to break this string word into 4 different partitions. Now note that if you have a string of length 4 and you have to break it into 4 different partitions, the only possible split is making one character each a partition, right? So the only possible split is G, 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 and G. And in that case, since all of these are same, the lexicographically largest or the output required would be G itself. So I hope the question is clear. Okay. So let's start with the solution. Okay, so the question was a bit long, so I would just like to confirm once, is the question clear? So it has got nothing to do with the length of the strings. No, it has got nothing to do with the length of the strings. Basically, when you are comparing two strings are lexicographically larger, if you get a string, if you get a character which is larger than the other one, then even if that string is smaller, that string can become lexicographically larger. For example, in here, you can see that BA, this is a smaller string, but still it is lexicographically larger than this string because B came before A. So I hope that doubt is cleared. Now let us try solving this. So I have some string of length n, right? And I have to break it into different partitions. The total number of partitions have to be num. So the total number of partitions I know in the given question, it has to be num. Why not solve an easy question first? An easy question. What if when num equals 1? If num equals 1, what will be the answer? Can someone quickly write in the chat if what should be the answer if num is 1? Correct. It should be the string itself, right? Because if num is 1, that means you have to break this entire string into a single partition. And that is possible only when you return the entire string, right? So if num is 1, the answer is simple. It's the entire string. It's the word itself. So this is trivial. We will handle this case separately in our code. So now, for all other cases, let me assume that num is greater than 1. So now we are assuming that num is greater than 1 and let us solve the problem. Okay, so while solving this problem, first let us make a few observations on what the length of the string could be. So suppose I have a string s1, s2, ... sn, and I have to break it into num different number of partitions. So I have to break it into num different number of partitions. And now my question to you is, what is the largest possible length of a string? So this is again a question. What is the largest possible length I can get if I break a string of length, suppose n, into num different partitions? Note that I'm not talking about lexicographically larger or smaller here. I'm talking about length itself. So what is the largest possible string I can get? Great. So I have answers in the chat which are exactly correct. It should be s.size minus num plus 1. Why so? Think about this, that if suppose I have broken the string into, say, num partitions. So suppose these are my partitions. So suppose this is my first partition, length of this is p1. This is my second partition, length of this is p2. And here and I have num partition. So it goes till p num. Great. Now I know that sum of all these pi's, which is nothing but p1 plus p2 plus ... plus till p num, that is n, right? Because sum of all these partitions has to be length of the string itself, right? Because when you concatenate all these partitions, you basically get the entire string. So the sum of all these partitions should be n. That is great. But there is one more condition. All of these partitions should be non-empty, right? Because that is what the question says. Look here. It says that the word is split into numFriends non-empty strings. That means all these PIs should be greater than equal to 1. So Pi is greater than equal to 1 for all I from 1 till num. So that means out of all these num values, these are all have to be greater than equal to 1, right? So what is the maximum possible value of P1? Think about this. Okay. So I had a condition that P1 plus P2 plus dot 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 plus P num. This is N, which is basically word dot size. Now I am asked, what is the maximum possible value of P1? Remember that P1 is the length of the first partition. Note that in order for P1 to be maximum, if we want P1 to be maximum, we basically need to set all the remaining values to their minimum, right? Because when all these terms will be minimum, then only P1 has to be maximum because their sum is constant. So I have to set all of these to their minimum value. What is their minimum value? 1, right? So I have to set all of them to be 1. And then I get the maximum value of P1 max. Now, how many of these are there? There are num minus 1, right? Because P1 is 1, there are remaining num minus 1 elements. So that means the sum of all of them is num minus 1. And this has to be equal to n. This simply means that the maximum value of P1, that is P1 max, is n minus num plus 1, isn't it? Great. That means I can never have a string of length larger than n minus num plus 1. So the length of the string would be either n minus num plus 1 or smaller than that. Also note that any string of length from 1 to n minus num plus 1, I can have that in my bag, right? So whenever I am making a split, so that means whenever I have this string s1, s2, dot, 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 sn, and I have to break them into num splits, I can have all strings, I can have all possible substrings such that their length is less than equal to n minus num plus 1. Great, isn't it? Okay, now that means the question boils down to the following. I have a string, let me call that word, and I have to find the lexicographically largest substring, find the lexicographically largest substring with length less than equal to n minus num plus 1. Great. So this is just so the problem boils down to finding this. Great. Now let us look what are the constraints given. So here the question says that the word dot length is less than equal to 5,000. Great. So that means n is less than equal to 5,000, right? Always remember in these type of questions that the constraints you have basically give you a hint on how to solve the problem. Since n is less than equal to 5,000 here, that means a big O of n square solution is acceptable. Great. So that means a big O of n square solution is acceptable. So why not just iterate over all possible strings? So that means why not just iterate? So why not do something like this, that I start in pointer for I from 0 till n, and then for j from I to n, and then I basically handle the string I comma j here, right? So suppose I make this string str, that is si till sj, and then I also maintain my max string. What is the max string I've observed, and I initialize this with empty string. And if I see that okay, my str is greater than mx, I just initialize mx with str. And I do this only when I see that okay, the length of the string. So if str is greater than mx, and if the length of the string, so that is here there's an and condition, and length of this string is less than n minus num plus 1. I can simply do this, right? So how many of you think that this solution works? Any idea? Okay. Uh, so is the code I have written clear? Like what the code is trying to do? It is just correct. So initially, so if you try to write this code, so it basically iterates over all substrings. First, check that whether this substring from I to j is of length less than equal to n minus num plus 1 or not. And if it is less than equal to n minus num plus 1, you just simply check whether it is larger with maximum or not, and then rewrite it with maximum, right? On first look, you may say that, okay, I have an outer loop of n size, I have an inner loop of n size. So this is big of n square code. Since n is less than equal to 5,000, this must be acceptable. But no, actually, this will give a TLE. So this will lead to time limit exceeded. Why so? Because here is the operation which is time consuming. This operation. In fact, even this operation. These two operations are really time consuming. Why? Because string is basic. What is string? String is nothing but a class of the C++ library, right? So, and here these operators are overloaded with comparison functions. So whenever you are using these comparisons, you can think of as if internally C++ is comparing these two strings one by maintaining pointers, just like as I discussed previously. So that means these operations itself take order n time. So that means you have a big O of n square loop, and inside you are again doing an order n operation. So that means basically the time complexity of this code is big O of n cube. N cube would be huge. It wouldn't pass for n less than equal to 5,000, because the number of operations you make is roughly 1e10 or something larger than that, which will obviously not execute under 1 second. So you have to think something optimal here. Okay. So here is a solution which you may try. So basically the idea is simple. I will just try to do some modifications so that I do not have this expensive big O of n operation a lot of time. So what can we do? So first maintain, just a second. Okay. Yeah. So I initialize an mx variable with an empty string. So here, this is the final solution. Look at how it goes. So I initialize this string with a final string, with mx with the initial string. And then and just similarly, I go for I from 0 to n. So this is the initial loop, which remains simple. So basically, I have this string, and here is my I pointer. And now I keep on increasing the j pointer from here. So this is my j pointer, which will again go from 0 to n. So it again goes from, so sorry, it goes from I to n. Great. Now I know that if this length I minus j minus I, this length becomes greater than n minus num plus 1, there is no point solving the problem, right? So in that case, I will just break. So if the length of this, so if length of this range ij is greater than this, then we simply break. That's clear, right? That's clear. But how do I solve the problem now? One thing I can do is I can maintain this string str. How can I maintain this string str? That's simple. that you just initialize an str here, and for every j, you just push back the jth character. So you just push back the jth character, isn't it? So you just push back word j. So this is something like you basically have a string. So suppose this is my s1, s2, dot dot dot. This is my si. This is si plus 1, and this goes till sn. This goes till sn. So here is my ith pointer, and my j is increasing. So every time my j is increasing, so what my string holds? Just a second. Yeah. So every time, so initially I've initialized string with, say, an empty string. Now whenever j is increasing, it is pushing this character inside str. So that means when I have reached, so when I have this, so I have this string s1, s2, and then I have an si, and then I have an sj, and then comes an sn. That means when I've reached here, I've marked str with si dot 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 sj, isn't it? Note that I am not completely forming the string at I and j. Rather, when I'm increasing j, I am just pushing this extra character inside str. So, and remember that pushing just a single character into a string is an order 1 operation, right? That is the reason this is not expensive. So in the ith and the jth character, I basically have this string. Now what I do, I basically check it with the max string. So I check it with max. Now there are few important observations you can make. The first observation is, if you ever find that str is less than mx, if you ever find that str is less than mx, then what then what you can do, you can just simply break. Why? Because this is a property of strings. Look like this. Suppose I have two strings. Suppose I have a string ba and I have a string ab. So which one is lexicographically larger? ba, right? So since BA is lexicographically larger, I can never add something on behind of AB and make it larger than BA. That is not possible. That is how the definition of lexicographically larger is. So even if I put Z here, Y here, X here, this inequality still remains valid. So that means if my MX is already larger than STR, there is no meaning increasing this J pointer. So if my mx is already larger than str, there is no meaning increasing this j pointer, because it will not because str will never become larger than mx. So this inequality will never change. So my mx will actually never get updated for this operation. So I can just simply throw away that execution and break it. So I hope it is clear why that if str is greater than mx, I never need to do the operation once. So is that clear? Uh, Someone please confirm, or at least confirm that it's not clear. Okay, great. So that means that whenever I am, so keep this idea in mind. So this is the basic code which we are trying to optimize. That we are going over all I and j and just, sorry, yep, this is the basic code we are trying to optimize. We are going over all I and j and just trying to do this. But what I said, first thing which I said is that if you ever see that mx is greater than str, then you simply break. So that is one thing which will help, right? Now, I read a chat which said that, okay, comparison will take order n time. That is true. Comparison will take order n time. But if you do this comparison, and if we ever see that, okay, mx is larger than str, you break, right? That means you are doing a comparison for order n time, but you are doing it only once. And once you do it, that execution for j will stop. That means it will start with a newer I. So that means you always think computer programs as something that there are some operations which are cheap, there are some operations which are expensive, and you basically need to do the expensive operations fewer number of times. Here, what we were doing, we were comparing it at for all I and j. So we were comparing it for n square times. So that is bad. but so we can't compare it for n square times. But if I write a break here, that would be great, right? Because then I compared it for one time, and then basically the execution for j ends. And then I will go back again here and start with a newer I. So I hope that is clear. I will show you the code, and then you will understand how the code is big of n square and not n cube. But just hold on for the entire idea. Okay, so I have this string again, s1, s2, dot, dot, dot. And then I have some si in between, and then I have an sj in between, and then I have an sn here. I have a string str which holds the substring si dot dot sj, and I have made this such that when I was increasing j, I was just pushing characters one by one. So making this was not an issue. It was just big O one operation per ij, right? And then I also have one string which I have maintained, which is mx, which is the maximum string I have seen so far. And we made one observation that, yeah, that if we ever find that mx is larger than str, then there is no point doing the execution again, and you just simply break and iterate for the next time. So I hope that's clear. Now, okay, so now what if I see that str is greater than mx? So suppose I see that str, just a second. So I see that str is greater than mx. So this is again a case. For str less than mx, we will simply break. We have seen this case here, right? So what if str is greater than mx? So here is the idea that if str is greater than mx, so suppose my mx was some random string aba, and suppose my str is some larger string, say z, y, z. So first thing which we need to do is we need to initialize mx with str, right? So we need to initialize mx with str. So this is something which we were doing in our order n cube code also. And we know that doing this is really expensive. We can't do it a lot of times. But note that once I have done this, so this ABA is removed. Now this ABA has became ZYZ, isn't it? So after this, once I have done this, I never need to do again initialize mx with str. So whenever I suppose now I have increased j, and I add one more character, say k, at the back of z, at the back of str, there is no point again comparing str with mx, right? Because I already know that mx has been overwritten with str. So instead of instead of comparing them and then again assigning, why not just add a k here also, right? Because adding a k keeps it lexicographically larger, and adding a character to a string is an order one operation, right? So I hope the idea is clear. So if you look at the code, let me show you the code once. You will realize what I'm trying to say. Yep, look what I have done. If k equals 1, so that is the case when num friends is 1, right? That is the easiest case. We have already discussed that we return the entire string because the string can be partitioned in only one way. That's great. And what is n? N is the size of the word. That's very cool. What is len? Len is n minus num friends plus 1, right? So this is basically the maximum length which is allowed. Great. This is my string mx, which stores the maximum string I have seen so far. So that is great. Now look at this. So I have, just as I said, that I have a loop for I from 0 to n. So that works. And then I have a loop for which starts from j, and it goes till minimum of n comma I plus len. So this is just to ensure that I never move more than len distance apart. So what we were trying to say is what I already said here, that suppose I have an I pointer here. So I have an I pointer here, and then I have a j pointer here. So this thing cannot be larger than n minus num plus 1, right? If this is greater than n minus num plus 1, you just break it. So that is the same way of writing, that you do not let j go ahead I plus len, right? So so that works. Now look what I have done. So here are things which I have done. We ignore this part for now. This I will explain. This is just string dot pushback word j. So this was something which I was explaining, that for that we have made this string by just pushing the jth character every time in the iteration. So this is clear. Now look at this. Whenever I see that whenever I see that str dot back is larger than mx str size minus 1, then we initialize mx with str. Let me explain what is happening here. So basically, let's so basically my suppose I have my iteration, so s1 s2, and then I have an si, and then I have an sj here, and then I have an sn here. So my str is initially empty, right? And then I started the operation. First my j is here. So first my j is here. So my string becomes si, because I've inserted this character into str, right? So now when I will compare it with mx, I do not actually need to make a comparison mx is greater than str or less than str, because that will be big of n time, right? Comparing the entire string is a big of n time. So suppose mx is at that point, suppose si is c, and suppose mx is at that point a b a c b, and suppose str is c. So I can just compare this first character with this character, isn't it? So that is what I have done. So I have just compared the str.back, so that is the last character of str, the character which I have just now pushed, with the same character, same matching character of mx. And if I see that str.back is greater than mx.str, so that means this character is greater. That means I am starting to get a larger string. So in that case, what can I do? I can just simply write str equal to mx, isn't it? Something which I just discussed here. Because I now know, because this character of string is larger than this character of mx, I can simply initialize with mx equal to str. But mx equal to str, I know, is an expensive operation. This will take a lot of time. So whenever I am writing mx equal to str, I am also assigning large as 1. Why do I do that? Large is a flag. When I initially mark large as 1, I now know that, okay, large is 1. That means I have started getting a larger string. So now I will not assign stuff, because I have already overwritten mx with str. So if I see that large is 1 in the next iteration, I will just push back the jth character and continue the iteration. So this is the same idea which I used here. That suppose my mx is aba, and I have some string zyz, and I see that, okay, this string is larger than mx, then I first overwrite mx with zyz, and for the next characters, I do not make a comparison or assignment again. I just take characters one by one and I insert them both in str and mx. So that would actually make things less expensive. So I hope this is clear. And apart from that, if I see that str.back is less than mx str.size minus 1, that means I have just seen that, okay, this character is smaller. That means I will always get a smaller string, and so I simply break. So this is the condition which I explained here. That, okay, that if I see str is less than mx, then there is no point and I can simply break here. So this was the code. So just quickly tell me what doubts you all have. Okay, why are we comparing the last character of both strings? Like, don't see it as if we are comparing the last character of both strings. It is, see it like that this j is increasing, right? So we are comparing the string character by character. Like, what actually happens is, so basically what happens is, initially your str is empty, right? So your mx is something. Suppose your mx is C, B, Z, A, suppose something like this. And initially your str is empty. And with every increasing j, you are basically inserting characters in this str, right? So first you insert, suppose C. So you inserted a C. Okay, great. Now what do you see? So there is no point comparing this entire character, this entire string. You can just compare this string, this character with this character. If here you have inserted D, then you know that D is larger. Okay, that means str has to be greater than mx. If you insert a B, then you know that okay, B is smaller than C. That means str has to be less than mx. So instead of comparing the entire string, because I know that will take a lot of time, I'm just comparing the newly freshly added character with this. So suppose this is C, that means the loop will keep on continuing. So I will add a, suppose now I added a B again. So now there is no point comparing the entire string, because this part of the string, I know it is already same, right? So I can just compare this character with this character, right? So this is again same. So now, we increase the pointer, the j value gets increased. Now suppose you have a U here. Note that you will not make a comparison for str and mx again, because you know that okay, this part is already same. Because if this part was not same, because what would happen if this part was not same? If this part was not same, either string would be lesser. In that case, the iteration will simply break, or string would be larger. If string would be larger, then large would be already 1. And if large is already 1, then we would have pushed max, word j into max, and we have continued, right? So that means since it has come into this execution, this part of the execution, we know that okay, the previous part of the string is the same. So there is no point comparing the previous part of the string. Why not just compare the last character of u with the same character with mx? If I know that okay, u is, now I've got to know that okay, u is less than z. That means str has to be surely less than mx. So this is basically the trick. How can I optimize time? Like look at the time complexity of this code. You have I, which goes from 0 to n. You have j, which is again an order n loop. Here, look what I do. These are bad operations. See, this is a good operation. You are just comparing two characters. Great enough. This is also a good operation. You are just comparing two integers. Great enough. This is also pushback, order one operation. Great enough. This is just a simple if with a pushback. Great enough. This is the expensive operation. Mx equals str. But note that I have written the code in such a way that if you ever do a mx equal to str, large also becomes 1. And if large becomes 1, then if in the next part of the iterations, it will never reach here. It will always continue from this part, right? Because large is 1, so it will get into this if, and then it will get continued. So that means that this expensive operation is executed only once. It is inside this j, right? So that means you have this in, and then you have this expensive operation which is which is executed only once for the entire j operations, for the entire n operations of j. So that would mean the time complexity would be n square and not n cube. So this is how the usual trick is to improve time complexity. Try to identify what are the most expensive part with regards to time in your code, and then try to update them, or try to optimize the code in such a way that those expensive parts are executed as less as possible. Okay. Can we do comparisons via hash, like polynomial hash in log n via binary search and apply previous logic? Probably we can do. Hashing is a technique which usually comes very handy in strings. Though I have not thought about it, but probably we can implement hashing also to solve this problem. Okay. You are asking what max str dot size minus 1 will give if this is empty. So if max is empty, then probably this will come into this if, and this if will give true. So this is just to handle the case when max is empty, or the size of max is less than size of str. And since this part will give true, so the compiler nowadays is usually smart, like it will understand which part of the code to execute first. So that would not be a problem. So I hope the second problem is clear. So let us start with the third problem of the contest. Because I have a few more, just a doubt explaining, saying to explain the back part again. So the idea is simple, that when I'm constructing this str string, I know that, okay, this part of the string remains the same. So instead of comparing the entire mx with str, because I know that is an expensive operation, I just compare the last character of u with the corresponding character in z. So str.back just represent the last character. If you try to run the code once again in your copy, you will realize that, okay, we actually need to do the comparison for str and mx. We can just compare the last character of u and z and understand whether str is less than mx or larger than mx or not. So I hope it's clear. Okay. So let's start with the third problem of the contest. Let us understand what the question says. The question says, count special subsequences. Great. You are given an array nums consisting of positive integers. A special subsequence is defined as a subsequence of length 4 represented by indices p, q, r, and s, where p is less than q, q is less than r, and r is less than s. And this subsequence must satisfy the following conditions. Nums p into nums r is equal to nums q into nums s. Okay. And there must be at least one element between each pair of indices. In other words, q minus p is greater than 1, r minus q is greater than 1, and s minus r is greater than 1. Okay. A subsequence is a sequence derived from the array by deleting 0 or more elements without changing the order of the remaining elements. Great. And return the number of different special subsequences in nums. Okay, great. So let me try to explain the problem. Okay, just give me a minute. Okay, so let's start. Okay, Vedit, you said that you have an unordered map implementation of it. So usually unordered maps have collision issues. So sometime you may get order n time collision clash. So that could be a reason of a TLE, though it is though I am not very sure, and it's difficult to say without having your code. Garv, you can ask a doubt in the doubt section probably, because it's very difficult to understand without seeing at the code. So let's start with the problem C. So what does the question says? So the question says that in the input they will be giving n integers a1 till an. Great. And it says that you basically, what do you need to do? You need to find 4 indices. So let me write this once again. So you have a1, a2, dot 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 an, and the question says that you find 4 indices. So you find a p, you find a q, you find an r, and you find an s, all in increasing order, such that ap times ar is simply aq times as. So it says that there are 2 conditions which needs to be satisfied. First, you need to satisfy that ap times ar is aq times as. Let me read the problem once, whether I'm right or not. So yeah, nums p times nums r is nums q times nums s. Great. So this is the first condition. And the second condition is that none of these things can be consecutive. That means there should be a gap of 1 between these two. So that means q minus p should be greater than 1, r minus q should be greater than 1, and s minus r should be greater than 1. Okay, great. So we have to count the number of such indices p, q, r, and s such that both these conditions hold at the same time. Great. So let's try to understand what is happening by looking at a test case. So let me have this 1, 2, 3, 4, 3, 6, 1. So I have 1, 2, 3, 4, 3, 6, and 1. Great. So now I need to find 4 indices P, Q, R, and S such that the 4 conditions hold here. Note that there is one solution I can actually see. So suppose this is P, this is Q, this is R, this is S. Okay, you can clearly see that nums P times nums R, that is 1 times 3, that is 3, which is same as nums Q times nums S, right? Because that is same as 3 into 1. So this is one solution, 1, 3, 3, and 1, P, Q, R, and S. Great. Obviously, we cannot find any other solution because there is no way to orient P and Q such that the gap between all these things remain 1, right? Probably this should also, you should also observe that if the size of the array is less than 7, so if n is less than 7, so the answer would be simply 0, right? Because if n is less than 7, you can never place 4 indices P, Q, R, and S such that the gap between them is 1. So if you look at the constraints of the problem, it already says that num.length is greater than equal to 7 and it is less than equal to 1000. So that is a good hint. So it says that n is less than equal to 1000. Great. So what is the brute force idea which comes to anyone's mind, right? So when I read the problem, obviously the brute force idea which comes to the mind is that okay, you loop P to 0 to n, and then you loop Q from P plus 1 to n. I have to take it from P plus 1, right? Because I want that the distance between P and Q is at least 1. Then you take R from Q plus 1 to n. Did I say something wrong? Sorry. Yeah, it should be P plus 2 to n. And it should be Q plus 2 to n. And then I take S from R plus 2 to n. And then I just check here that, okay, is AP into AR same as AQ into AS? So, and then I will increase the count if AP times AR is AQ times AS, right? So this is a simple code. This, what is the time complexity of the code? This runs in n to the power 4 time, right? Great. Okay, but what is the value of n given? Sadly, the value of n is given as 1000. That means n to the power 4 would be order of 1e12, which will definitely not pass and it will give TLE. What is now you should understand that since value of n is 1000, the optimal code which you have to give is something order of n square or an order of n square log n code, right? Nothing worse than that. Nothing worse than that would give a TLE. So this gives a hint that okay, since the actual time complexity I ask, okay, so this gives a hint that since the actual time complexity I ask for is big of n square, then there are only 2 variables I can loop on. I cannot loop on all these variables P, Q, R, and S. That would be terrible. That would be n to the power 4. So we have to choose 2 variables on which we have to loop on. So can you all guess which 2 variables to choose to loop on? Just guesses. Or if someone solved it during the contest, what variables did you choose to loop on? Okay, many of you chose P and R. Great. I think there are multiple solutions for the problem. You can actually choose any 2 set of variables, and they should probably work. Though I'm not sure how can we write a solution by choosing P and S, for instance. But for all other combinations, probably a solution can be written. When I coded it up, I usually find it comfortable taking the first 2 variables. So I wrote by choosing P and Q. Many of you said in chat that you used P and R, which may be perfectly fine. But let me show you a case where you can iterate over P and Q. Okay, great. So first of all, so I have this array A1, A2, A3, and then I have an AN here, right? So suppose this is my Pth index, and here comes my Qth index. P and Q are the two variables I'm iterating on. So I have basically in my code, you can see a loop for P goes to 0 to N, and for Q goes to P plus 2 to N, right? So, something like this. Now, now the problem is I can't loop out much. So inside this, I cannot write a loop that would give order n cube or n to the power 4 time complexity, and that would give TLE. So that means this part of the array is still unexplored, right? Now remember this, it is usually done in competitive programming that when you can't, when you have to optimize time, you try to save that by storing earlier results in memory. So like if you look at the previous code which we have written, it does not use memory, right? Just a second, where did I write that? Yep, here. So if you look at here, it is an order of n to the power 4 code. This was the time complexity, and the space complexity is order 1, right? So now the idea is reducing the time complexity to something lesser by increasing the space complexity. So we will store some results in memory so that it actually helps to improve the time complexity. How can we do that? First of all, let us understand what is the subproblem we are trying to solve. We are trying to find all indices. So I have fixed P and Q. Now I try to find all indices R and S such that AP times AR is AQ times AS, and S minus R is greater than 1, right? And obviously R minus Q is also greater than 1. Great. Now realize this, why not play with this condition? AP times AR is AQ times AS. I have complete information about P and Q, right? So I fixed them. So why not take P and Q on the same side? So that gives me AP by AQ is AS by AR, isn't it? So that means this fraction AP by AQ has to be same as this fraction AS by AR. So why not write a code? Why not write a code which iterates over P and Q, So since I am iterating over P and Q, I know the values of AP and AQ. Let me compute the fraction AP by AQ. Let me compute the fraction of AP by AQ. And I know for the condition to satisfy, AP by AQ has to be equal to AS by AR. And somehow find how many pairs S comma R are there such that AS by A pairs R comma S are there in the right hand side such that their ratio is same as AS by AR. Basically, my idea is, so this is what my idea. My idea is, let's make a map. I will change the implementation a bit. Now I'm just explaining the logic. So let me make a map of a fraction, and an integer. And let me call this map frec. So this basically stores the frequency of a fraction. Okay, great. So now I have to start from p equal to 0, right? So my p equal to 0 and my q equal to 2. So if my p is 0, if my q is 2, I know the value of AP by AQ, right? That is simply A0 by A2. And that should be equal to AS by AR. So why not in the map store So in the map fric, why not store all those pairs r comma s? So I suppose I have found this fraction and the value of this fraction is f. So why not why not fric of f, store all the number of possible pairs r comma s such that they are at least one distance apart in this right hand side and their ratio is f. That can be done, right? So basically what my idea is, so this is what is the idea of the problem. The idea of the problem is, first make a map fric. This map fric will store the frequency of all fractions. This map will store the frequency of all fractions. Basically, it will store count of all r comma s pairs. So basically, fric of f will store count of all r comma s pairs such that as by ar is equal to f. And obviously, r comma s should be a valid pair, so s minus r should be greater than 1. So what I'm saying is, we start looping on q. So suppose this is my q. So this is my q, which is say equal to 2. Q can never start from beyond 2 because then you will never get a space to insert p here. So suppose q starts from 2. When q starts from 2, why not? So I know that r has to be something from 4 and onwards, right? So why not in my fric map store all the possible store the frequency of all the fractions? Basically how many pairs r comma s are there such that their fraction value is equal to f? So I store it in the map fric. Now I start looping p backwards. So p starts going to so this is the p pointer which starts going to backward. As I go backward, I know the ratio aq by ap. So I know the value of the fraction f, and then I just add fric f to the answer, because that for that particular choice of p and q, I know how many pairs r comma s are there such that their ratio is also f. So if you think about this, if you just look at this part of the code, you will realize, ignore everything which I have said. I will explain a lot of parts must be unclear here, but look what I'm doing. I am iterating over q. So q goes, and then there is a p pointer which moves behind q, like it goes from q minus 2 and it is decreasing. And every time I have increased my answer with the frequency of the fraction. So this is basically the idea. Okay, let me just do a simple, for example, let me take this test case 3 4 3 4 3 4 3 4. So this is my test case 3 4 3 3 4 3 4. My q starts from 2. So this is my q equal to 2. And my p starts from 0. And at the initial moment when q is 2, my fric is a map. So it contains the frequency of all the fractions in this region. Because if this is q, I can start r from here, right? So in this region, I store all the possible fractions of r by s. So what are the possible pairs here? You can take this and this. In that case, value will be 3 by 3. You can take this and this. The value will be 4 by 3. You can take this and this. The value will be 4 by 4. These are the only possible fractions, right? These are the only possible pairs of s comma r, and their ratios possible. So this value is 1, this value is 1, and this value is 4 by 3. So in my map, I have stored that, okay, the frequency of 1 is 2 and the frequency of 4 by 3 is 1. This I have stored in the map. Great. Now this is my q, this is my p. So this is my q, this is my p. I know the ratio ap by aq is 3 by 3, which is 1. So now, since I know the ratio is 1, I just count how many pairs are there in this region which have a ratio of 1, which I can find in this fric array. So I know that there are two. So I know that there are two pairs of R, S such that their ratio is 2. So that means I do answer plus equal to 2 here. I do answer plus equal to 2. Great. Now I will increase my Q. So the same problem. Now my Q will get increased. So 3, 4, 3, 4, 3, 4, 3, 4. So initially my Q was here. Now my Q is here. Great. And now my map contains the fraction of the fractions of only this part. So what are the possible fractions? There is only one possible fraction I see, that is 4 by 4, which is 1. That means now my map contains the number of pairs of only one. There is only one fraction 1, which is a frequency of 1. So this, understand what this map contains. This map contains number of valid pairs R, S such that As by AR is F. That is what frec of F contain. That is what the information frec of F gives you. So this is Q. Let's start from here. This is P. So what is the ratio AP by AQ? It is 1. So now it will look in the map and ask, okay, how many pairs are there with value 1? So there is only one pair with value 1. So it will do answer plus equal to 1. Great. Now the value of P will reduce. P will come here. And it will ask, okay, it will ask, okay, what is AP by AQ? That is 3 by 4. Great. Now, how many ratios are there? Pairs of R, S are there such that the ratio is 3 by 4. It will look in the map. It will not find it. So that is 0. So it will simply do answer plus equal to 0. Now Q will move here. So this is the next part of the iteration. Q has moved here. P will again start from here, and the frec will contain information of these last two things. Obviously, in these last two things, there is no valid pair of R, S possible. So frec will become empty. So rest all other iterations will just add 0 to the answer. But this is how you get a 1 first, and then 2 initially, and that is the reason you get a 3 to the answer. So, and you can see that the answer to this is 3. So is the idea clear? There are few catches which I will explain. Okay, but is the idea clear? Like what is the frec map storing and how are the iterations done? Someone please confirm in the chat once. Okay, great. So basically, so that is the idea. Now, there is just one technique which I'm telling you, which will actually come handy in a lot of problems, like not this problem, but you will see many problems where you have to store a map, where you have to basically store the frequency of fractions. So you need to store the frequency of 3 by 4, you need to store the frequency of 7 by 6, you need to store the frequency of 8 by 3. So here are a lot of techniques which lot of times you will face such problem. And usually I do not recommend using long double for this. Like for doing this, you can obviously make a map of say double comma int, isn't it? So whenever you have a value 3 by 4, you can say, okay, suppose this map is frec, then you can simply do frec of 0.75 plus plus. That is obviously an idea which is possible, but usually with double, especially when the numerator and denominator can be large, there are precision issues. So that is the reason I do not usually recommend storing these form in the form of double. Rather, it is always great that if you store these things in the form of a pair of integer. So instead of making a map of double comma int, what is always better to make a map of a pair of integer. So map of a pair comma int. Basically, the idea is that instead of saying that, okay, frequency of 0.75 plus plus, you just write that, okay, frequency of this pair, frequency of this pair 3 comma 4 plus plus. Basically, this only demonstrates the idea, okay, 3 by 4 is once again encountered. So, but here there is a catch. Usually the problem is that suppose I give you two fractions, 3 by 4 and 6 by 8. When you store it in the double, you say, okay, 3 by 4 is 0.75. You do it, a simple pointer float calculation, and then you store, okay, a freq of 0.75 plus plus. Here also you do the same thing. 6 by 8, okay, that is also 0.75. So freq of 0.75 plus plus. The problem comes when you try to use this in the pair form. Like when you will store 3, 4, you will say do, okay, freq 3, 4 plus plus. But now when you will store 6, 8, you will do freq 6, 8 plus plus. That's wrong, right? These are two same fractions, and you have stored them as different forms. So when later I will ask you, okay, tell me how many how many 0.75s are present. This will give the correct value. This will say, okay, two 0.75s are present, but this will give the wrong value, because I will ask you how many 3 by 4s are present. You will say there is only one 3 by 4 present, but actually you have stored one 6, 8, which is essentially 3 by 4 only. So in order to handle this issue, basically the idea is just store all fractions as their simplest form. So reduce them and store it in the simplest form. How can you do that? So basically, whenever you need to store numerator by denominator in the map, but just divide them by their HCF. Right, like the HCF of 6, 8 is 2. So you just divide them with 2. So that will help storing the fraction in the simplest form, and then you can store it in the map. So that is the idea. And then the later part is simple. Now you can look at this code. This part just uses the GCD using the Euclidean algorithm. This computes GCD in logarithmic time. So I'm skipping the explanation, as this is quite standard. Apart from that, so this is where I have actually made the initial map. So note that my map stores pair of integers and integers, and I call it frequency. So here I have stored the initial map. So the values of all pairs of R and S, I have stored their frequency of the fractions. And while storing the frequency of the fractions, I've ensured that I divide them with their HCF. So this is what it does. Apart from that, I keep a Q pointer, and then a P pointer goes backward, and then for all possible pairs of P and Q, I just compute nums P and nums Q their HCF. I compute the fraction, which is nums P by nums Q, storing them in the simplest form, and then I simply increase my answer with the frequency of the fraction. Okay, and this is actually an important part of the code. This is actually an important part of the code. When I'm just a second, yes, here when I'm increasing the value of Q, I need my initially my frequency was storing this. So suppose my Q is here. So when my Q is here, my frequency map was storing this part, right? Now when I will increase this Q to here, my map will store only this part. So that means my frequency map also moves one side to the right every time. So every time my Q increases, I need to ensure that I throw away the fractions of the map which has this value of R. Right? So when my Q is here, just, okay, let me explain it a new page. Okay, so this is suppose A1 dot dot dot, and here comes AQ, and this is AQ plus 1, this is AQ plus 2, and this is AN. When my Q is here, my map contains the information, my frequency map contains the information of this suffix of the array. But now when I increase my Q from here to here, my map has to store only this part, because this difference has to be kept 1, right? So that means from the map, I have to throw away all the possible values where Q plus 2 was stored in the denominator. So that is what I have done. I have initialized R with Q plus 2, and then for all possible values of S, I have actually from the map reduced their frequency, or removed them from the map, because now I will actually have to work on a smaller map. So after this, I just compute, increase the answer for every such value, and then I finally return the answer. So that was the idea for the problem. Uh, oh, okay, sure. Let me explain this. Basically, I am just iterating over all possible values of P and Q and getting the answer, right? So so there are many ways to do it. Like you could start a P here and then a Q here. Like I have done like Q goes from 0 to n, and then I've done P goes to Q minus 2 to 0. That is a completely valid way of doing it, right? Like there is no catch in understanding why P goes backward. Like I could have simply written it like this, that P goes from 0 to Q minus 2 P plus plus. I could have actually written that. There is no point, like there is no catch here. Basically, this is same as saying that I have a Q pointer which is moving, and then I iterate over all possible values of P in the back. So I have to iterate over all possible values of P in the back. I go forward or backward, doesn't matter. I have gone backward. You could have easily also gone forward and got the same answer. Okay, so you have reduced frequency, but what if it reduced down to 0 and then you have to erase it? Yes, okay. Yes, the slowly frequency array will actually get reduced down to 0. And in that case, you will always add 0 to the answer. So that would not be a problem. Because adding 0 to it will not be a problem. Okay, this is a good question. What would be the time complexity for it? Okay, this is actually a very good question. I just forgot this part. First of all, okay, so what is the time complexity? Okay, let me ask, any guesses? What is the time complexity of the code? And what is the space complexity of the code as well? Any idea what it should be? Great. So if you look at the code, it's better always to analyze time complexity by looking at the code. If you look at this part is Q and P. So that is big of n square. Big of so this first of all, this is a big of n outer loop, because this runs for order n number of times. Here I have two inner for loops. Both of them run for n times. So this is big of n square. That is clear. What we are doing inside this? Inside this, we are first of all making a map access. So okay, and we are also finding GCD. So let me understand what is, so what are the values given? So num size less than equal to 1000. So basically, if I say, okay, if I say that, okay, so the time complexity is big of n square log of n square plus n square log of AI. This part comes because n square times I actually make a map access, and the size of the map is n square itself, right? The size of the map is n square. There are n square different possible fractions stored. And this comes because AI is the size of a value, and it takes log of AI time to compute the GCD. Also, and I could simply write that because log of n square is simply 2 times log n, and we can throw off constant factors while writing the asymptotic time complexity. So this is big of n square log n plus n square log of AI. Okay, so I hope the time complexity is clear. We can also discuss the space complexity. The space complexity remains big of n square because we use a map which stores frequency of n square different fractions. So the space complexity of the code is big of n square. So I hope it's clear. If there are doubts, please ask me in the chat. So is it clear? Okay, great then. Thank you for understanding the PCD. Okay, Divyansh, actually the submission links would be shared, so it would not be an issue. So I hope it is clear. That's all for today. If you feel any problem, you can always fill the feedback sheet. Let's meet later. have a great day and have a great new year too. Thanks.